So people typically use static objects to prevent players from falling out of the map or just going somewhere they shouldn't be. But if you have a big map, or if it's just easy to fall out of, then placing a bunch of kill boxes can work, but it's a bit inefficient and can eat up more memory. So what you could do instead is do that whole process entirely by using node graphs. Okay, so I'm in a random test world. There's nothing much going on. And if I start the game and I just run towards this hole, then I'll just keep falling forever. So typically games would have like a timer that once it reaches 0, then the main game starts. So let's make a start game timer, and let's say the cooldown is 5, sure. And let's make that start game, and let's check, well, let's add a UI component so we can see how the progress of the timer is. And I'll just move that up here. And I'll change it to countdown and look for the start game timer. I'll also just rename this to start game, spelled correctly. And I'll go to my stage entity. I'll add a component, global timer, advanced editing, specify timer, and start game timer. Perfect. Now if we go to the node graph and create a node graph, I'll just name this boundary check. Because we're using a global timer, then we should use this event which checks for the global timer. And we'll use a branch, which is basically an if statement that checks if the name of the timer that is triggered is equal to the start game timer that we inputted in the timer management. So if this global timer is triggered, then we should start a separate timer. This one isn't global, and it should be the target entity should be from the event source. And the timer name, let's just say it's bound check. And we'll have it loop. And because this takes in a list, let's just add in an assembly list and have it loop every 4 seconds, because we don't really need it to have we don't really need it to loop every single second, but 4 seconds is fine. And because of that, we can use a timer event to execute the main part of our code, which helps make the actual boundary. So if we look for when timer is triggered, and we use a branch, and we check that the timer is equal to the name that we have up here, boundary check. And we say that this is true. Then we want to execute a loop that iterates through a player list. And with that player list, we can check what the player's Y coordinate is. But in order to get that, we first need the character of the player component. So we have to query for the character. So with this player value, we can input that in here. And we can get the first character component from this list. And with that character component, we can get the location, get entity location. Then with the location output, we need to get the split method. So we can just extract the Y coordinate from the player. And if the Y coordinate is less than or equal to -5, then we have to kill the player or teleport them to a certain location. So let's say teleport player, and we need to use this player entity, since that's what the teleport player method wants. for some reason instead of character, but yeah, let's just go with that. And then we just input the values. And this should work. So basically, every player that's in the game is having this loop, is having this check being ran. So every player is being asked, is my y coordinate below -5? Is it below -5? And that's being ran every 4 seconds. So every 4 seconds, the game checks if a player is below the map, and if they are, then they're teleported at this location. That is basically what all this does. You can of course make this another a bigger number if you wanted to. Let's say -15, maybe -20. You can make that anything. It doesn't have to be -5. You can see our timer. Now that's 0. If I jump through, say get teleported up, jump through again, wait a bit, and I get teleported up. And that happens every 4 seconds. So yeah, that's pretty much it.